Hello all, this is Dr. Pallavi Taude. Today we are going to check Banker's algorithm. Banker's algorithm is a resource allocation and deadlock avoidance algorithm in OS. It is named after the way a bank might allocate its available cash among multiple customers to ensure that it can satisfy all withdrawal requests without going into insolvency. Let us check the first example. So over here you can see a table with four processes. Allocation for the two resources are given. Max allocation required by the processes are given and availability of the two resources is given. So you can see the complete table is divided in four parts: process, process allocation, process max requirement and current availability. Over here we have two resources R1 and R2. And two questions are asked. We have to check and we have to calculate the need matrix. And second, we have to determine if the system is safe or not. So first we will calculate a need matrix. To calculate a need matrix, we have a formula as need is equal to max minus allocation. So we have four processes. So P1, P2, P3, P4 we have written in the first column, and then in the second column we have calculated the need. As we have R1 and R2 resources, you can see over here we have mentioned R1 and R2 resources. Then we have mentioned the need is equal to max minus allocation. So you can see over here the max availability is 9 comma 5, that is the max availability, and the allocation is 7 2. So you can see 9 minus 7, that is 2, and 5 minus 2, that is 3. So that is the need of P1. Similarly, you can see for P2 the max availability is 2 and allocation is 1. So 2 minus 1 1, 6 minus 3 3. So that is the need for P2. Then again for P3 you can see max minus allocation. So max requirement is 2, allocated one is 1. So 2 minus 1 1, that is the answer, and 2 minus 1 again 1. So that's the answer for P3. Requirement is 1 1. P4 the max allocation is 5 and 0. So 5 minus 3, so 2 is the requirement, and 0 minus 0, that is a 0 requirement. So over here you can see four processes are given and we have calculated the need of each process, and availability table is given. Now we have to cross check using Banker's algorithm whether we can satisfy the request of each process or not. If we can satisfy the request of each process, the system will be safe. So we require the need matrix again and again, and we require the available resource. So R1 resource is available in quantity 2 and R2 resource is available in quantity 1. So let us check with the help of Banker's algorithm whether the system is safe or not. So this is the need matrix which we have calculated right now. So I have kept it over here for the reference, and we know we have 2 comma 1 resource availability. So if I want to apply a Banker's algorithm, the formula said need must be less than equal to availability. So step 1, 2 comma 3 is the need for P1, that is the first process, and the availability is 2 comma 1. So whether out of 2 comma 1 we can give 2 comma 3 resources, it's not possible, right? So 2 comma 3 is not less than equal to 2 comma 1. 2 out of 2 resources we can give 2, but out of 1 resource we cannot give 3 resources. So that's why this condition is false. We cannot do the allocation for the P1 resource as the need is more than the availability. Step 2, you can have to check for the second process. So second process require 1 comma 3 resources. The availability is 2 comma 1. So you can see out of 2 I can allocate 1, but out of 1 I cannot allocate 3. So that's why P2 request also we cannot satisfy. Need is not less than equal to availability. So we cannot allocate the resource for P2. Now you can see P3 requirement. P3 requirement is 1, 1. So 1, 1 is the P3 requirement and available resources are 2, 1. So out of 2, I can allocate 1. Out of 1, I can allocate 1. So P3 request we can complete as the condition is true. Now the new availability we have to calculate. New availability is equal to old availability plus the allocation of the process. So once the process is over, so P3 is the process for which we can satisfy the request, we can give the resources to P3. Then the P3 will be executed, and after execution what it will do? It will deallocate the resources. So once its use is over, it will do the deallocation. So that's why we have to calculate new availability as old availability plus the allocation of the process. So old availability, old resources which are available with us, they are 2, 1 and 1, 1 was the need of that P3 resource. So as it has deallocated is 2, 1 plus 1, 1 is 3, 2. This is the new availability which we have. Step 4, now we will be checking for P4 whether we can allocate the resource or not. So 2, 0, that's a requirement of P4 and the new availability is 3, 2. So out of 3, I can allocate 2 resources. Out of 2, I can allocate 0 resources. That means need is less than availability. So condition is true. We can complete P4 resource. As the P4 resource will be over, whatever resources it is holding, it will deallocate it for others. So that's why new availability we have calculated 3, 2 is the old availability plus 3, 0 is the allocation for the P4 process. So that it will deallocate. So 3, 0 we have already given. So you can see 3, 0 that is already allocated to P4 and 1, 1 which was already allocated to P3. So we have deallocated P4 resources because of which we can calculate the new availability. Now it is 6, 2. So this is the new availability. So now again we can check with the help of this new available resource we can satisfy the request of P1 and P2 or not. So 6, 2 is the new availability and P1 requires 2, 3. So 2, 3 it's its requirement and 6, 2 is the availability. So you can see out of 6, 2 we can allocate, but out of 2 I cannot allocate 3. So that condition is false. So we cannot allocate the resource for P1. Similarly, we will check for P2. So P2 requires 1, 3 and availability is 6, 2. So out of 6 I can allocate 1, but out of 2 I cannot allocate 3. So the condition that is need is less than equal to availability is false. So that means I will not be able to execute P2 also. So P1 and P2 will not be over. That's why the system is unsafe. We have allocated the resource only for P3 and P4, but we are not able to allocate the resource for P1, P2. So that's the reason system is unsafe. So we have calculated the need matrix and then we have checked whether the system is safe or not. One more example we will try. Again, we have a table with a process allocation, max and availability. Over here you can see there are 5 processes, there are 3 resources and we have given the allocation max and availability for each resources. We have to calculate the need matrix. We have to check whether the system is safe or not. And we have to check whenever the new request is coming, whether we'll be able to satisfy that request immediately or not. So let us first calculate the need matrix. So need matrix we can calculate with the help of formula. Need is equal to max minus allocation. So you can see this is the max column minus the allocation is nothing but the need. So we can see 7 minus 0, so 7, 5 minus 1, so that is 4, and 3 minus 0, that is 3. So this is how we have calculated the need for P1. Similarly, we can calculate it for P2. 3 minus 2, that is 1, 2 minus 0, that is 2, 2 minus 0, that is 2. Similar to this, we have calculated the need for all the processes. Let us check for P5. 4 minus 0, so need is 4. 3 minus 0, so need is 3, and 3 minus 2, so the need is 1. So this is how we have calculated the need for every processes. So that's the first step, calculate the need. Now let us apply the Banker's algorithm. I have kept the need matrix over here for the reference. What is the need of each process? So we have resources A, B, C, and we have to check whether we can do the allocation for process P1 first, then for P2, then P3, then P4 and P5. If for all process we can do the allocation, the system will be safe. So just check first for the P1. We have to always check the formula. Need should be less than equal to available. So need for process P1 is 743 and availability is 332. Availability is given in the last column. You can see the availability over here is given as 332. So each time we have to check whether the need is less than equal to availability. So in this case it is false because out of 3 I cannot allocate 7. Out of 3 I cannot allocate 4. So that's the reason condition is false. We cannot do the allocation for P1. That means we have to check for the next process P2. Again, the formula says need less than equal to availability. So the need for process P2 is 1, 2, 2. We have to check with availability. So condition is true. That means we can allocate the resources for P2. Once the P2 process is over, its need is over. That means whatever resources it is holding, it will reallocate it. Okay, so new availability we can calculate. New availability is equal to availability plus the allocation of P2. So we have to check what was the allocation for P2. So 332 is the previous availability and we have to check allocation for P2. So just check the table what was the allocation for P2. So allocation for P2 was 200. So once the P2 is over, its resources are free. So that's why new availability we can calculate. So 332 plus 200 is 532. Similarly, now we have to check for the P3 process whether we can do the allocation for P3 or not. We have checked the need for P3 is 600 and the availability, which is the new availability, is 532. So out of 5, I cannot allocate the 6 resources. That's why the condition is false. Now we have to check for P4. The P4 requirement is 011. Availability is 532. That means condition is true. We can do the allocation for P4 process. So P4 will be over and whatever resource it is holding, it will free it. So previous availability was 532 plus the allocation of P4. So you can see what P4 was holding. So P4 was holding 211 resources. So to calculate the new availability, we'll be saying old availability plus the availability or the allocation for the P4 process, which is 211. So we have just added the allocation and the new availability is 743. Now we have to calculate for P5. Whether for P5 we can do the allocation. So P5 require 431 as the need and the availability is 743. So condition is true. That means we can do the allocation for P5 process. Once the P5 will be over, it will release its resources. So new availability is 743 plus the allocation of the P5. So you can see the allocation for P5 was 002. So that's how we can calculate the new availability. 743 plus 002 is 745. Now first and third process still we have not executed. So you have to try for P1. So again we will check the need for P1, that is 743 and the new availability is 745. Now the condition is true, that is need is less than available. So we can allocate the resource for P1. Once the P1 is over, it will free the resources which it is holding. So 745 plus the resources which is available with P1. So P1 was holding, you can see the resources as 0, 1, 0. So that we have to add. So you can see 0, 1, 0 is added and the new availability is 755. Now we have to check for the P3 resource. So P3 need is 600 and availability is 755. So 600 is less than equal to 755. Condition is true. That means we can do the allocation for the P3 process. Once the P3 process is over, whatever resources it is holding, it will free it. So new availability will be the previous availability plus the allocation for P3. So the previous availability is 755 and the resources which P3 was holding. So you have to check what resources P3 was holding. It is 302. So 302 we have to add. So you can see 302 is added. So that's why the new availability is 1057. As we are able to execute all the processes like P2 first we have executed, then P4, then P5, then P1 and P3, the system is safe. And the last question was asked, what will happen if the new request is coming as 102? Whether we will be able to accept this request immediately. So 102 is the request coming and we were having the availability as 332. So you have to check the last column for availability. So you can see availability is 332 and we have a request as 102. So obviously we can allocate the resources for P1 process because out of 3, 1 I can allocate, out of 3, 0 I can allocate, out of 2, 2 I can allocate. That means system can accept this request immediately. So condition is true, request is or need is less than equal to availability. So the condition is true, P1 gets immediately all the resources. So that's how the banker's algorithm works. Thank you all of you for watching this video. If you found this video useful, please like and subscribe to the channel.